Hi, everybody. Wait. This is so cool. So, okay, did you see the animated banner? What is the point of continuing with this charade? We're done. We can just leave, you know? It's done. We've done all that there needs to be. Okay, well, whatever. We didn't get a photo, okay? We'll just pretend like you're happy just this one time. Okay, ready, steady, open source. Open source. Come on, folks, say the words. Very nice, thank you. Oh, good stuff, look at that. We have very little time. We only have 70 minutes. Also, this code, by the way, this code is available here. We totally didn't wait until last moment to prepare these slides.
We never do that.
No. Is that right?
Yes.
Yeah, there you go. There's all the bits you need. So we're going to go through a lot of stuff today. We have a lot of stuff to cover. If you want to follow along at home, please do. Don't hesitate. Find the Git repository for your own reference, for your own edification, for later. But like I said, we're happy to answer questions after the talk because we do have a lot to go through. So there's that. Anything else to add to that, my friend?
I don't think so.
I'm just so impressed with all these wonderful people, you fools. Yes. Lock the doors. Lock the doors. All right, so very good. So there's that. We're going to talk about reactive Spring today, and you saw a good bit of it in the keynote this morning, so that's very good. Hopefully that'll whet your appetite. What we're talking about here isn't new or novel, right? This is not a particularly novel thing or a new idea. We've long had the need to be able to describe systems or to be able to handle large amounts of I/O, right? We've long had this need to be able to handle large amounts of data and to build systems that conduct that data efficiently. As you saw in the keynote earlier, they talked about this sort of the discrepancy between the way synchronous, sort of traditional servlet-based programming models work versus reactive. The idea here is that when you build a distributed system, when you move to this idea of microservices, you end up building a distributed system, and in so doing, you introduce a lot of complexity, right? And we've talked about that complexity before. We've talked about ways to introduce patterns to support getting around that complexity or simplifying it whenever possible. But one thing that still lingers, and one thing that people still have questions on is, okay, if I have a large amount of data, and these are services talking to each other, they're conducting data over the wire as opposed to intra-process, how do I make sure that these services can keep up with each other, right? If I have a producer producing data and I've got a consumer consuming data, how can I make sure that one doesn't overwhelm the other? Additionally, how do I do the most with the available resources I've got? In a traditional servlet model, as we saw earlier, you've got the cat taking up the swimming pool lane. In that traditional servlet approach, you've got a thread wrapped around a server socket, waiting for that server socket to finish processing the response to send it back to the client, even if that production of that response takes forever. Maybe there's a gap. Maybe the production of that response itself is waiting on something else downstream. And it doesn't need to be. It's just I/O, but it's happening very slowly. Perhaps there's latency. Perhaps it's another microservice call. Whatever. The point is there's holes in that response. There's time where the producer is trying to produce a response, but it's waiting for something downstream. Maybe the data is taking too long, whatever. That gap is an opportunity for the thing that's producing data to do other work, but it can't. The thread that it has allocated to handle that response is waiting for the whole thing to finish before it can be reused. So the question is, how do we make better use of that thread? How do we make it so that other things can handle that thread? Well, we have to change the fundamental way we deal with input and output. We have to support what's called asynchronous I/O. And this isn't a new idea at all, right? In 2001 or 2002, in Java 1.4, we introduced Java NIO, which gives us channels, right? How many of you write all your code in terms of Java NIO channels? Nobody, right? I mean, there's two people, but I think he's just trolling. That's a troll. It's a troll. The point is, it's very, very painful. Nobody purposely does that unless they're in some very, very specific use cases, right? It's very painful, so nobody does it just using directly channels. Nor do people write stuff using Java I/O input stream and output stream. When was the last time you wrote your data access layer and your web tier directly in terms of input streams and output streams? You didn't have higher order abstractions sitting atop that made the work easier and more cognitively easy to swallow. So we need some way to support these kinds of requirements, to be able to support a large amount of data that may overwhelm our consumer. We need to be able to support more efficient utilization of the resources that we have in the meantime, including, and most specifically, referring to threads. So we need some way to talk about asynchronous I/O. And again, a lot of technologies have this. The operating system at the lowest level has this. Your network I/O layer in your operating system by default is asynchronous, not synchronous. It's only in the JDK with Java I/O and input stream and output stream that we pretend that things are fundamentally synchronous, but they're not. So we have channels, and that's an option, certainly, but it's very low level, it's very painful. And so we've looked for a long time for a computing metaphor that allows us to talk about data that may be available, but not now. It'll be available in the future, right? So we need some way to talk about that. In the JDK, we have the ability to return, we have methods, for example. You can return a value of string or a collection of string. That's a single value or a collection of values. And that's a synchronous blocking kind of operation. We can say, I've got a single value that will be available asynchronously, or eventually. That's a completable future, right? But what about if you have multiple values that may be available asynchronously eventually, and we want to be notified? For this, we've lacked an idiom, And so a lot of different vendors in the space, we've all sort of sought for a way to solve that problem. And eventually, we all converged on something called the Reactive Stream Specification. Just a few years ago, we created something called the Reactive Stream Specification. There, we defined a new type called a publisher. This Reactive Stream Specification was jointly authored by the people at Pivotal, by people at Netflix, by the people at Red Hat on Vertex, and the people at Lightbend, nay TypeSafe, working on Akka and Akka Streams. All these people worked together to create a de facto standard that extracts the fundamental types needed to describe this idiom of asynchronous, eventually available data. The fundamental thing that they provide is something called a publisher. A publisher is an object that produces data that may be available. A subscriber can listen to that publisher. It can say, I want to be notified of new data. And the subscriber can say, when it subscribes, it is given a subscription. And when it has that subscription, it can use the subscription to signal to the producer that it can only handle 10 records, say, or 100 records, or whatever it is capable of processing at a time. That ability to signal how much a consumer can handle and to push back, that's called back pressure. This is a fundamental quality in flow control. If you've ever built any kind of distributed systems protocol, you know you have to build in that protocol some notion of flow control. Well, this is built into the API now. It's built into the idiom for building systems. This is how you build systems that can't be overwhelmed. The consumer is responsible for taking on more load. It is the one that controls the flow of data, the consumption of data, not the producer, right? You can't denial of service a reactive consumer. So we have this, and we have this thing that's asynchronous, right? It's a notification. It's a callback. So now if I'm doing asynchronous I/O at the lowest levels of the operating system, I have an API level. I have an API abstraction that lets me talk about data eventually, as opposed to here's the byte, wait for the next one, right? So we have the reactive stream specification. That's a good start, but it's not really enough. We still don't write code at that level, right? Most of us write code in terms of higher level abstractions. What good is all of that if you can't build a REST API, or if you can't talk to their data tier, or if you can't do security? So the real boon, the real benefit of Spring Framework 5, which was just released in September, and all the stuff you're going to see demoed today, is that it's an integration, a holistic sort of all-encompassing integration of all these pieces to support this fundamentally different approach to building services. So you saw some of that in the keynote today. I think that was a great keynote, by the way. But we're going to go through a lot of stuff today, like I say. So get the bits there. We're going to start our journey today at start.spring.io. We're going to build a new application. This is my friend Mark and I. We struggle with what kind of demo we should build. We had a lot of discussions, and he kept on peppering in these arcane movie references. Jokes.
It's been known to happen.
Yeah. Terrible, terrible, funny jokes.
Just terrible.
Just terrible.
Just terrible.
So we're thinking, what kind of domain could we build? And he kept on peppering these movie references. So we didn't know what we could build, and I felt suddenly the need to look up movie references. We got lost in a tangent there. Anyway, eventually we settled upon building something related to movies, right? And we thought, wouldn't it be great as a demo to build something that allowed us to work with movies? And again, another word for a movie is a flick, right? An idiomatic, old-timey word, a bit of jargon for that word is a flick. And we thought, well, we've got this Reactor project. And this Reactor project has two types that specialize, this publisher that I told you about, the publisher from the Reactive Streams initiative. There are two types that are specialized from publisher. One is called a flux. A flux is a publisher that produces 0 to n values. It's still a publisher. It just has a semantic, it's specifically meant to be unbounded. Whereas a mono is a publisher that produces 0 or 1 value. You could treat them all as publishers, and your life would still be fine. But you get some semantic awareness by talking about them in terms of as fluxes and monos. If you're creating a user interface and you want to just figure out whether you should display a table or a single text field, now you know, right? A mono is probably a single text field. You should use a grid or a table if you've got a flux. So we thought, OK, we've got this reactive project. We've got this idea. We've seized upon this idea of creating a thing with movies. Movies, an old-timey word for movies on the internet, that's a flick. We could do a service that was based on movies on the internet, some sort of service that let us talk about many movies, which would be flicks, right? Many movies on the net. Some sort of thing related to the Reactive project. And we thought, aha, that's it. We'll call it Netflix. And so in order to build that, well, we need a service that let us talk about flicks using Flux. We could call it the FlixFlux service. Short for FFS, or for Flux sake. So we're going to build a new project here at start.spring.io. This is our second favorite place on the internet, of course. First favorite place is production. We're going to build a new application with the reactive bits, right? This is 2.0. This is Spring Boot 2.0. This will be released either this month or next month, but very, very soon. Either way, sorry. It'll be released very soon, so you'll have those bits if you need them. Right now, it's we're inching very, very steadily to a finished release. We're going to call this. We're going to use Spring Boot 2.0. We're going to do some examples using Kotlin. We're going to do most of it in Java, but we want the ability to be able to drop into Kotlin, so I'm going to use the Kotlin language here. And we're going to create a new service. We're going to just call this FFS. And we're going to use the reactive web support. We use Lombok. We use Actuator for observability concerns. We are going to use some sort of database, right? We have a lot of options here. You can see there's reactive web, but there's also a number of different data technologies, data options, right? These options are integrated in Spring Data, and we've surfaced them as part of Spring Boot. So a lot of different options here, right? A lot of different options that we could use here. I don't have Redis or Couchbase or Cassandra on my local machine, so we'll go ahead and use MongoDB. It also lends itself to our domain model, right? It's a nice fit for this. It's a good document database. So we'll use that. Here we go. Good. All right. Anything else?
I don't think so. I think that should work.
We could switch to the full version. A lot of options, but I think we're OK with what we have here.
Well, we do only have till dinner time, so.
Right. Good. OK. So moving on. So hitting generate. That'll give us a new project, and that's here in the downloads directory. Whoa, whoa. All right. All you, my friend.
All right. Well, let me step in first by saying that I am the talkative one of the two of us. So, just high energy here. I do want to say that I don't know if anybody has ever seen Tommy Boy, the movie. Anyone? OK, yeah, classic, right? So you remember the skit about the fat guy in a little coat? Well, no, that's me actually.
Oh.
We have different hardware. So I use a Mac all the time, and Josh uses a Linux machine. So I am the Mac guy on a Linux box. OK, let me try that again. Fat guy in a little coat. Mac guy, never mind. OK, so anyway, so you're going to see, we usually trade off when we do this. So last time we used my Mac, and Josh was suitably uncomfortable, and we had some really good laughs. So this time, I'm it. So I'm the comic relief. Please don't laugh too loudly or too long when I mistype things. And when I really get in a jam, I just call him over. So let's start with this. So let's get this rolling. And while that opens up. So we're going to open this project up in our favorite IDE, which at the time, for now at least, is IntelliJ. So let's go ahead and get rolling. I'm going to, I guess, first go to the main application.
Can you see that font in the back, my friends?
Oh.
No, OK.
So let's see.
Oh. Yes.
Oh, hey, look at that. Not doing too badly. So let's see. So font. Here, yeah, just crank this up, right?
Yeah.
So let's do, well, I was going to say 36. Let's see.
How about that in the back?
Is that good?
Who can't see it? Raise your hand. Okay, so make it a little larger just in case.
A little larger, okay. So just wanted to see me find the system properties again. So let's go with 42, maybe?
Who cannot see that in the back? Okay.
Okay, move to the front. No. I'm just kidding. Let's do this really quickly. Okay, so we're starting off, and of course, since Josh chose on the initializer Kotlin, we're actually starting off with a Kotlin main application class. I'm going to just change that so that we can just start off with Java. So let me go in here and really quickly just rename this. Refactor, rename, oh, no, rename file. Cancel. Yeah, see, it's starting already here. So refactor, rename file. There we go. So I'm just going to change this from a Kotlin file to a Java file, which then, of course, IntelliJ barks at us a little bit because it's radically unhappy because it sees that this is definitely not Kotlin, or not Java. So we're going to make some changes here just to kick things off. So let's see. We're going to start off with that. And it begins already. So let me go back. There we go. OK. So the first thing we're going to do is make this a public class. And then let's take this main function. And let's see. Can I move that up? Yes, I can. So nice. All right. So we're going to, I guess, next, tab that over. And we're going to change this to a public static void main, mostly. OK. And again, with the Kotlin arguments, we're going to just change this to the standard string array that that Java expects. String args, and let's see here. And then we'll change this. This isn't awkward at all. So spring application.run, and we're going to take our main application. Whoops, too quick on the trigger class. And args. OK, so we're pretty much in good shape now. I just need to add the semicolons that Java expects and that Kotlin doesn't, and we're up and running. So that gets us back to a Java starting point. So now, where do we go from here? When we're talking about our movie service, yes?
Screen bigger, Alt1.
Oh, OK, yes. Better? OK, so when we're starting off, where should we start? Well, let's start with our model. So we'll define our class, our movie class, kind of makes sense. So we're going to create some member variables here, like our ID, also maybe a title for our movies, and that will get us off at least to a running start. We're going to be storing these in Mongo, so we annotate this with that document. And we're going to be using Lombok to make short work of our getters, setters, our equals, hashcode, toString, things like that with our data class. I'm also going to annotate this and have Lombok provide our noargs constructor, and then a required args constructor, which then I'll go ahead and annotate our ID field. And then, of course, since we have a required args constructor annotation, we need to let Lombok know what is required. That's the title. So now we have a single argument constructor. And that's effectively our model, except this is about, this is about streaming movies. So we need to get some operational visibility, some insights into how our movies are being streamed. So what we want to do is create a movie event class, because if we have a movie that's being streamed several times a second, we probably want similar movies like that or a collection, right? If we have a movie that's only streamed once every year or two, that's probably pretty safe to drop from the library. So we're going to keep track of things like a movie ID, and for instance, like the date when it was streamed. So date viewed. So let's see. Boom. Nope. Yeah, working on it. You'd think by now that keyboard layouts would be standardized. Guess what? And key mappings, but not so much. OK, so again, we're going to be using Lombok. So we ask Lombok to provide our noargs constructor and all args constructor, and we're off and running. That gets us our model, but now we need to create a repository for our movies. So a movie repository, and we'll do that by extending our reactive CRUD repository, which is in Spring Data. It's an interface defined there. So we can store objects of type movie with IDs of type string. And this gets us our basic functionality if we want to extend that functionality with something that isn't provided in Spring Data, because Spring Data will provide the capabilities to find all, to delete all, to find one, to delete one by ID. But if we want to perhaps create a flux of movies, wow, there we go. Let's see. Nope. Go back here, Alt, Enter. Oh, happy. OK. To where we can find, perhaps by title, and pass the title. We can do that. Title, spelling is important. So that gets us up and running. But it's not very visible, right? We have nothing that we can see happening. So it's always nice to, being very visual people, we like to see the movies that we're dealing with. So let's create some. So I'm going to create a bean, an application runner bean, and we'll just call this the method demo data, and we're going to pass in our movie repository, and we're going to create some movies. So let's see, return args, because application runner is a functional interface with a single abstract method. We're going to provide the lambda for that, the implementation for that. So let's get started. Let's create a flux of just these movies. So let's have some movie titles.
Absolutely.
And this is where we really shine because we're masters of bad puns, right?
Terrible.
Terrible puns. Terrible. Save yourself. But we don't care about all the other movies, the non-reactive themed movies. We just care about the good stuff.
Right.
Right?
And this is the most important part of the session, really.
It is.
We want you to help us. And if you think of some, what we want is movie titles.
Yes.
In the theme of sort of reactive programming and functional programming and so on. And so, we want movie titles that relate to these things. Can I kick us off with a suggestion from our friend?
Sure, please.
Our friend Phil Webb gave us my favorite suggestion, which is Silence of the Lambdas. And if you have others, just throw it out there. And again, even if we have arrived at a few of them now, and you think of them later,
yes, please.
Go ahead and throw it out. We'll stop and come back. This is important.
Data-driven, OK? So garbage in, garbage out, we have to have some really good titles.
Yes.
Otherwise, we're just
Who else has got some?
Back to the Future. Oh, yes, because?
Flux capacitor reference.
Right.
Anybody here watch anime? AN Flux, yeah?
Yes,
there you go.
heard that. OK, so let's see. There we go. Anyone else?
Anybody else? Bueller.
Meet the Fluxers by chance? Maybe?
Yep.
Yeah.
Fluxinator.
The
Flux Gordon.
Fluxinator, right? Flux Gordon. Yeah, there we go. OK. Anybody Cuarón fan? Y tu mamá también? OK, we can change that.
Yeah.
Actually, that has a couple of bonus features to it because instead of doing y tu mamá también, which is translated in your mother as well, we're going to make it y tu mono también, which actually in Spanish, mono means monkey, so that's a double. That's a twofer. Wow, that didn't really...
I liked it.
I liked it, yeah.
You got me.
Whatever. OK, well, tough crowd. Anybody else? Going?
It said in the abstract, didn't it say in the abstract we need movie titles? Bring your titles? No?
Seriously, fail.
Fine.
OK.
Okay.
If you think of one down the road, as Josh says, please just stop us, yell it out. We will circle back. That's fine. We are not above that at all. So we have a decent selection of titles. So let's take those titles and we'll map them. So we'll create new movies from those. So there we have our titles. And then let's flat map those, right? So we take our movies, and we will take our movie repository and save each of those movies, right? And then we can subscribe just to kick off the party, right? So we can see what's going on. Visibility is a good thing, as well as the terminal operation kind of kicks things off. It starts the flow of data. And that's OK. We can probably improve this just a little bit. We can replace the lambdas with method references, and that tightens things up just a bit. But there's a problem. There's not a bug, because we don't bug our code. It saves time. That way we don't have to debug it, right? But there is a problem here, because even using Mongo, and we're going to restart this several times as we go, but even using Mongo, some of these records will be saved each time we restart. Probably not all.
Not always, definitely not always.
But some.
But some.
It's bound to happen. So we really probably should do some housekeeping first, right? So let's start with the movie repository .delete all.block. Is that good?
No, please don't do that.
Yeah. I mean, if you start seeing block, I mean, it's obviously a valid operation. It's in there. It's in the API. But if you start seeing block creep into your code,
And this is
probably
Josh
should-
Block.
Yeah, okay, that'd work.
Yeah.
Yeah, that'd work, but that's different spell.
Okay.
But you should probably question your life choices at this point. So we actually can replace this with an operation that does a then many. It takes a publisher. When the publisher is complete, it goes ahead and produces a flux. So let's do that, because right now what we've created at this point is, coincidentally enough, a flux, right? Yeah. So we can take this and let's clean this up. Oh, there we go, good. I just wasn't hard enough on the keys. Apparently Linux likes a heavy hand, so. And that's okay, you know. That gets us each one as it's coming in, so that's not bad, but it doesn't really test what we're getting. It doesn't really test what's already out there. So let's take our flux, and let's do another then many, right? And we'll just actually do a movie repository dot find all, which coincidentally enough also produces a flux. So we should be in business here. Let me go ahead and just clean this up and make sure that, just make sure that that works. And boom, and that seems happy. So now let's run this. Nope. Nope.
Function.
There it is.
There we are.
Okay, good. Good, and it didn't even shut down, so that's a plus.
No,
yeah,
no sig fault, nothing.
Yeah.
Didn't have to recompile the kernel.
We actually probably should do this too, because as we go along, you've selected it. Excellent. Yeah. Okay, nice.
All right.
Okay, so we see some data out here, so that looks pretty good, right? So at this point, we've written reactively our data to the repository. We've written it all the way down to Mongo, and most of it, well, it looks like all of it's in there.
Yeah.
So hey, things work. So now at this point, probably what we should do is create our service, right? Our internal API.
One thing that I think that's really interesting about this is if you were to print out the thread on each one of these chained, like we've got several things that are happening here in a pipeline. We've got delete, then many, and then many again. Oops, that was terribly.
Oops.
We got those different stages of the pipeline. If you were to put out, if you were to print out the name of the thread, you'd see that there's no reason that they have to be on the main thread. We've got things that seem like they're written in an imperative way, happening in a sequence, and they will happen correctly in a sequence, but behind the scenes there's a scheduler. And that scheduler can move this stuff onto different threads. We don't have to worry about how it's being done or what threads it's being done on. You can change it if you want to, but the point is, as long as you write it using this API, stuff that is implicitly concurrent will still behave correctly. It's deterministic, you know, you can understand what's going to happen.
Yep. Okay, so at least we have our database access covered, right? So at this point, let's create our internal API. We'll create a service. We'll call this, again, cleverly enough, our movie service. And let's inject our movie repository here so we can access that. Again, build on things. Let's see. Yay, right keystroke. Okay, we're off to a great start. Okay, so what is a minimal API that we can start with? We probably will want to return a flux of all of our movies, right? So we can see what all we have in the collection. So we'll call this get all movies. We also will probably want to be able to find a particular movie, right? Mono of type movie. Yep, and we'll call this get movie by ID. So we can search by ID, if I can type, string ID. And then we also will probably want to, again, operationally see what's happening in terms of our events. So we'll want to return a flux of movie events, right? Get events for a particular movie ID. So let's go ahead and build out our API, our internal API, return this.movierepository.find all, and that's pretty much a pass-through, right? Return this.movierepository.find by ID, once again, a pass-through. That's pretty straightforward. Here's where it gets a little stickier because we don't have a million customers at this point. If we had a million customers all streaming movies all the time, we would see a lot of these movie events just firing all the time.
Just one at the moment.
Yeah.
Not even paying.
Yeah, because I haven't even signed up. So, you know, but later, I promise, I will. Okay, so at this point, we kind of have to fake it, right? We're going to generate some movie events just so we can see what's happening. So I'm going to do a flux.generate. I'm going to create a sync and just create some movie events. So a new movie event using the movie ID in question. We'll give it a timestamp here, and that will produce just a ton of movie events, just as fast as this Linux machine can produce them, which is really remarkably fast, actually. So for the purposes of our demo, I'm going to slow things down a little bit so we can kind of see what's going on. I'm going to delay the elements and just basically create one as a ping, as a pulse, one every second. So that gets us most of the way there. IntelliJ is kind of barking at me here because it's expecting a flux of type object. I'm actually wanting this to be a bit more specific here. I'm going to ask it to produce a flux of movie events, specify that. And that looks pretty good. Should work.
Should, yeah, famous last words.
If only there was a way to test code.
If only.
If only there was a way to test code before you put it into production.
That's not a thing.
Yeah, it's not. But actually, you know, I learned something because watching the keynotes earlier, Madura had this really cool idea, which is, and I talked to her later, she said that there was this key combination you could use. Let me see if I've got this right. Oh, it is. It is. Look at this. So we're going to try something new and entirely uncharted right now. I'm going to create a test. So please bear with us. We'll see if this actually works. I don't really necessarily care about testing right at the moment. Not ultimately, but at the moment, the get all movies and the get movie by ID. But this one has me a little concerned, this get events. So let's make sure that this works. I'm going to just annotate this with run with, let's see, spring runner.class, and we're going to annotate this as a Spring Boot test, which gets us all of our Spring Boot goodness. And then I'm going to auto-wire in, let's see, private, our movie service, so we can access our internal API once again here in our test as well. That's always good. And then I'm going to try to give my test a little more descriptive name, because that's a good thing, right?
Yeah.
Right? So I want to make sure we can get 10 events. That's the purposes of our test today. So we're going to start off, just grab a string, a movie ID. So let's see, we'll do a movie service.get all movies.block first.get ID. Now, this is one of the rare cases where it's okay to block, is in a unit test. Because
where it can harm nobody.
It can harm nobody. We've got this kind of walled off. But the idea, of course, is that you know, when you're dealing with a blocking model, testing is, relatively speaking, much more straightforward. Because you're issuing a request, you're getting a response, you test the output, right? But when you have a flux that may produce 3 values in 3 seconds, and then another value in another 3 minutes, and then another one in a week, that gets to be really difficult to test, right? That's tough. Yeah, it makes for really lengthy unit tests. So what we're going to do is just grab an ID here. We're just getting the first one off the heap, and then we're stopping there. Reactor gives you the capability, which this is the second best part of the whole presentation, I think, my opinion only. It gives you the ability to time travel, okay? Really? Nobody? Okay, well, time travel is cool. Plus, it speeds up your unit test. So what we're going to do is use step verifier, and we're going to use virtual time. Now, we know, because we wrote the initial method, that we're going to get back a value every second, and that's fine. But what if you don't? What if you don't know how many values you're going to get in whatever amount of time? So we're going to use with virtual time, and we're going to create a supplier. So let's see. We're going to access our movie service. Do a get events for this particular movie ID we just grabbed, and then we're going to take 10 of those. This is an example of back pressure. This is a consumer, a subscriber that's saying, I can only take 10 at a time. Maybe it's 5, maybe it's 20, but we're just saying give us a limited number, and then we'll go ahead and continue from there. At this point, we'll do a then await, right? And we will provide a certain amount of time that we want to wait. I'm going to just play it safe and do a, let's just say 10 hours. Because if we're going to time travel, we might as well do it in style, right? So we know we're going to get 10 values in 10 seconds, roughly. Let's wait 10 hours, just to be safe. And then I'm going to expect next count of 10, because we know we should get 10 values at the other end. And then we're just going to verify complete. And that should work, right? So let's see. But that's why we test. So let's see. Let me see if I have that right. Do not show. Stop and rerun. Off we go. This testing thing, I think, it may be big.
Yeah.
Oh, I didn't run this. Here, how do I?
Right click.
Yeah, I'll just default to this.
Or,
there it is. So let's run the test. And we should get a green bar, which is great, because it means one of two things. Either your code works, or your unit test doesn't. So what I like to do is just verify my unit test. I'm going to give it a bad number. We're going to expect 11 values. And then let's see if we have that.
Never gets old.
Yes. Mac guy. OK, yeah. All right, so that works, or it doesn't work in this case, and that's fine. So I'm going to just change this back, because I'm kind of obsessive compulsive. I like to make sure everything clears with a green bar. And once that happens, we'll go ahead and move forward.
All right.
Testing. works. So let's close that out. And let's close out the test. And let's go back to our code. So we have our internal API established. Now we should probably create our external API. Now there are several ways to do this. This is really great. If you're coming from a Spring MVC perspective, as Phil showed and Madura and Stefan, that you can actually leverage REST controllers. I'm going to take things in a little different direction right now because if we have time, we'll come back to that. If not, we'll just charge forward. Excuse me. But what I'm going to do is define our routes in a functional reactive manner. So what I'm going to do is let's see, I'm going to create a router function. Oops. Here we go. There we go. OK, so router function. And I'm actually going to leverage our movie service so that we can go ahead and, again, use our internal API. So now let's return router functions dot route, and let's define our routes. So the first thing we're going to do is establish a request predicate dot get, and we're going to create a get endpoint. So let's start off with our movies endpoint because we know we want to query that, right? And let's take our request, and we expect to return a server response, right?
It goes outside the parenthesis.
What?
Got an
Oh, you're right. No. You're right. Darn it, I hate that. OK, so we're going to return a server response. We're going to assume everything's OK with an OK. And let's create our body. So let's leverage our movie service dot get all movies. And we're going to return objects of type movie. So that's pretty straightforward, right? That gets us our first route. Now we want to add another route. So let's create another request predicates dot get. We're going to hit our movies endpoint. Only this time we're going to actually grab a movie by its ID. So now I'm going to take that request, and once again, I'm going to leverage our movie service dot get movie by ID, and then I'm going to take the request and extract the path variable. Once again, we have our path variable over here, which is our ID, and I'm going to grab that and leverage that in our get events call, or get movie by ID call. And once again, I'm going to add another route. Yes, I missed something again?
server response.
Oh. Yes, I did. I get so excited and move so quickly sometimes I just forget. So this is a server response.ok.body. Boom. And let's move that all within here. Boom. And that's that. And that's that. So of course we need to, once again, establish we're going to return objects of type movie. And add that. And then we're back in business, right? Yes, and route. So let's take our request predicates once again, do another get. Let's access movies slash ID, and let's grab the events for a particular movie. So now let's do a server response dot OK. And this time it's a little different, right? Because our movie events are not going to be shipped up and packed up and shipped in a bundle. Because we know that our events are going to be pulsing out at about 1 per second, just over an indeterminate amount of time. And Webflux actually provides some different mechanisms for dealing with that, things like WebSocket support or server sent events. Now, since this is a one-way push of data, server sent events makes a lot of sense. So I'm just going to specify a content type here of media type dot text event stream, which indicates that we're passing server sent events here. And then I'm going to use this to create a body, movie service dot get events, once again grabbing the request. Let's see, request. Oh, did I skip that part? I blithely skipped over that part, didn't I? Yes, I did. So once again, we define our Lambda parameter. And let's just double back there. So we take our request path variable and extract our ID. And once again, we are in business. And that's pretty good, right? That's not horrible. What am I missing here?
Movie event, that class.
Oh, yes, thank you. So yes, we need to return objects of type movie event. So this isn't horrible, but it's a little verbose. And of course, since we have things kind of cranked up to the larger font size, it makes it a little harder to read. But we can clean this up just a bit. So I'm going to use some imports here to tighten this up. And let's do the same thing here. And once again here. So that makes things actually pretty readable, right?
Rename the variable for movie service to just MS or something. Fits most of it.
Sure. So let's see.
There you go.
So how do I propagate that?
And just Shift F, function Shift F6.
Yeah, that's so intuitive.
Control Z.
Okay, so Control Z.
Function Shift F6.
Function Shift F6.
Oh, yes.
And S.
Enter.
Enter. Wow. Okay,
Sweet
you don't have
nectar.
anything like that on Mac. That's so awesome. Okay, so now we're up and running, or we will be up and running. So let's go ahead and restart this.
You hear that sound, that cracking sound?
Oh.
He tried to do the key command and his pinky broke.
It's been known to happen, right? Okay, so run application. When all else fails, go back to the mouse pad. So, okay. So it seems to work, right? It would be really cool, again, if we could test this somehow. So let's do that. Let's hit http://8080/movies, and let's grab our movies. So not bad, right? We're hitting our movies endpoint. We're getting movies. That's working as expected. So let's see if we can break it. Let's grab a particular movie ID. Whoops. What just happened there? Okay, so this should just work, right? Yes, look at that. Okay, so boom. And the ID, it retrieves by ID. So let's see if we can get our events.
So that's the streaming operator. You're going to stream the
Yes,
certain events?
we're going to stream the events, and so far it actually
Looks
kinda
great.
works. Yeah. So let's see. Do we have enough time to go ahead and launch into the Kotlin version, or do you want to roll forward? And if we have time, double back.
Yeah, do the Kotlin version.
Do the Kotlin? Okay. Wow. Excellent. Okay. So this works.
I can do it. I'll do it in the next one, actually.
Okay.
That's fine. Okay. That's awesome. All right. So thank you for that. So this is the functional reactive endpoint. This is the support it's unique to Spring 5. There was no equivalent to this before. If you've ever used something like Spark Java or Sinatra in the Ruby world, or Scalatra in the Scala world, you'll have noticed that this is very similar to that. It's a very convenient program model. You can choose either or. As Mark just said, this is actually a little tedious on such a large font and such a small screen. We did it just to sort of highlight that you've got this one expression here. You've got the request matcher, the request predicate, and then the body. This is a little tedious right here. Of course, you can use a lambda, a longer lambda if you want to make it a little bit easier to understand, or use a method reference, right? Like this is Java 8. So you could extract this out to another class that has the signature that's expected by this lambda, and then substitute a reference for that method for this expression, right? So that
You have options.
You have options, exactly. All right, so we've got now a service. It's pretty good. I think we could almost push it to production. One thing that we should have is, of course, support for production concerns like observability. And observability these days refers to this very simple idea that no matter what organization you talk to, no matter what their technical stack, no matter what their business vertical, no matter where they are in the world, one thing seems to be very consistent, which is that when the pager goes off, somebody gets woken up and has to figure out what's going on. And everything we can do to help that process, to move it along as fast as possible, is valuable. Spring Boot supports that with the Spring Boot actuator. So we have this in Spring Boot. This is not new by any stretch for Spring Boot 2 or anything like that. But what is worth reiterating, and what was talked about ever so briefly in this morning's keynote, is that the actuator now works independent of any particular web runtime. So you can support it in Spring MVC style applications, Spring WebFlux applications, and of course in Jersey. So there's that. I should mention that you can do old Spring MVC style REST controllers as well. So here's the movie REST controller, just a very quick re-implementation of the stuff that we just saw there before. So I'm just going to steal Mark's work. Wouldn't be the first time today. Let's see. Here we are. And I'll say @get mapping movies flux of movie all right. I'm going to inject the movie controller here. I'll say private final movie service. Create a constructor for that. I'll say return this dot movie service dot get all movies. There's that. Great. I want to have a flux that returns all the movie events. I'll say just events. And of course, in order for me to determine what movie this is for, I should inject the movie ID. So let's see. I'll just call this ID @get mapping movies ID. This dot movie service dot get by ID, right? There's that. Pass that in. And mono of movie. Thank you. Events. All right, by ID. There's that. And one more endpoint for the movie events. That was a melange of both of those in that last one. path variable string ID, return this dot movie service dot get events, passing in the ID as before. And this time, just as before, we have to take care to signal to the client that this is not just JSON, that it actually is a particular type of data type. So we'll use the media type text event stream configuration there. So that is functionally exactly the same as what you just saw here, right? And you can choose either or. I'm going to comment this out only because I can have two mappings for the same endpoint, two components purporting to handle the same endpoint, but they will work identically. Now that's the REST controller, that's Spring MVC style, but underneath the hood we're still using Spring Web Flux. We're using a reactive runtime. So you notice that we're not in any place injecting the HTTP servlet API here. We don't have access to it by default. Right now our web tier is Netty, right? That's the default, right? We see it says Netty started on port 8080. You can use Tomcat, you can use Jetty, you can use all the other embedded sort of options, but by default, when you're using Spring Web Flux, you get this brand new Netty-based runtime. So there's our application, and as going back to what I was saying a minute ago, we also need production concerns like observability. So I want to actually expose those endpoints. I've got them on the class path, but I want to expose all of them just to show that those work as we expect as well. So these are, what I'm showing you here is that it's a brand new, wonderful, reactive, wild world, but things you are used to, like the actuator and Spring MVC style endpoints, those are still there as well. So curl, HTTP, localhost, or HTTP 8080/actuator/health, right? So there we are. There's the health endpoint. There's the metrics endpoint. Data that you're expecting. Now, of course, these actuator endpoints, for example, the metrics, are backed by a new project called Micrometer. So that's a separate project that we are now using for Spring Boot 2.0. That's why the output looks a little different from what you may have been used to in Spring Boot 1.0. All right, so we've got a service. I could see that going to production. That'd be a very nice thing to have there. But this is my API. I'm expecting clients are going to want to talk to this API, and I don't want them all talking to the API directly because there's a lot of things I'd like to do to support different client-specific concerns. So we call that an edge service, and that's what we're going to do now. Is we're going to build a client that is an edge service that talks to this service. We're going to do that here at start.spring.io. We're going to build a new service called FFC, and we don't need the reactive Mongo support, but we want Redis gateway, Spring Cloud Gateway. And we want security, okay? Yeah. So we're going to bring in those bits, and we'll hit generate. This is also a Kotlin project. Remember, I haven't changed anything else other than just the dependencies I specified here. So here we are, UAO. I got the wrong one, didn't I? FFS. Whoa. Goodbye to that. What did I name this? FFC. Sweet. Okay, here we are. UAO FFC.zip. And take some t.bottle. All right. So we're going to write this application using Kotlin, right? This is because there's a lot of things that lend itself to functional programming and reactive programming in Kotlin. So I'm going to go ahead and leave almost all of this as it is right now, except for this. I'm going to go ahead and remove that. And what I want to show you is I'm going to create a Spring application, and Spring, of course, has this notion of objects that get wired together. We call those beans. And the wiring, the knowledge of that wiring is what makes Spring so powerful. It's its ability to interpose behavior or services along the seams of those objects that makes it so valuable. And there's a number of ways that it can do that. It can support it through old-style XML, which, don't do that, but you could. It can support Java configuration, right? Which is to say you have a configuration class which has bean provider methods. That's certainly an option. It can also support component scanning. So you have objects that are annotated with @component or @service or @REST controller. You've seen us do that just now. In fact, I just did REST controller. He did a service earlier, a number of other things. So these are all options. We have a new option in Spring Framework 5 called functional bean definitions. And of course, I'll talk a little bit more about this later today in a talk called that, functional bean definitions or something like that. Spring tips, find that if you can. But for now, suffice it to say, what we want to do is we want to take advantage of that. That's a different style, and it's nice because it's more natural if you want to register lambdas, for example, as just a bean. You want to have a quick way to tell Spring about some objects. You don't want to have to create a whole configuration class and all that stuff. Okay, so here we go. What we're going to say is a Spring application builder dot run. So I'm just porting the invocation that we had here before back to this approach. We'll come back to it in a second. So FFC application class Java. There we are. So this is where we're going to do what we have to do for the functional bean definitions. We're going to say beans And it's a DSL here. You can do this in Java, by the way. It's just not nearly as elegant. We have the ability to create an application context listener in this initializers element. This is what that takes, application context initializer, rather. And I'm going to use a DSL here from Kotlin, Org Spring Framework Context Support beans. And there, I'm going to register different beans that I care about. Since we're building an edge service, our edge service is going to talk to our downstream service. It could do that in terms of a service registry. It could use Eureka, and we have a reactive integration for Eureka, the service registry, or any other Spring Cloud service registry. You can talk to them reactively. But for our purposes, I'm just going to go ahead and use a localhost 8080, hard-coded string. Just keep that in mind, though. So in order to make those requests, I'm going to create a web client, right? So we saw Madhur and Stefan talk about this a little bit earlier today. So I'm going to create a builder. It's going to have a default URL, right? HTTP localhost 8080/movies, right? And I think that's it. There we are. I'm going to build it. So that's all I have to do. I'm creating a bean definition. And I'm registering it with Spring. I'm telling Spring, hey, this is the object I want you to manage for me and to make it available for injection anywhere else I need it, right? So there's my bean definition. I'm going to create another one here. I'm going to say bean. And here, what I want to do is I want to register a route. Let's just have a custom edge service that adapts the data from the downstream endpoint to the response that the client expects. Remember, all clients have different requirements. Some have bandwidth constraints, some have security constraints, protocol constraints, some have different views that they need, different synthesized views on the data. So we're going to adapt the data from the downstream service. We're just going to return the names of the movies, not all of the JSON, just the names, stripping away the surrounding JSON strata, the IDs, and so on. So we're going to create a new endpoint, but here we're going to use the Kotlin version of the API that Mark introduced us to just a few minutes ago, the functional reactive endpoint style. So here we're going to say router get, right? Whoops. Spring framework, okay. So I'm using a DSL here, right? This is the router functions dot route that we saw earlier. I'm using a DSL, and I'm going to say whenever somebody calls movies, titles, we're going to say server response dot OK dot body, and what we want to do is we want to take the data. Let's say val names equals, it's a val of names, and it's going to be a name of title. It's going to be a publisher of titles. So we're going to come back to that in a second. I'm going to send that back here, names, and that's it, right? There's my updated data. I'm using Kotlin here. Notice that I don't have to specify the second parameter there. In the first example, Mark and I, we looked at the fact that you can use the body method there to return a publisher, and then as a second parameter, you have to specify a class literal that tells the publisher of what type each element in that publisher is. The reason you have to do this is because Spring needs to know how to frame the messages that get sent back to the consumer, right? Think about it. Think about how typical JSON marshalling or XML marshalling works. You look at Jackson, for example, the default behavior that you've been used to in all of Spring before is that it waits for the end of the document, whatever that is, the XML document, the JSON stanzas. It waits for the whole thing, turns the object into that JSON, and then writes that out back to the client. But what happens now when you've got 1 trillion items? Right? You can't wait.
Over time.
Yeah, exactly. Coming over 10 hours. You can't efficiently sit there and wait for all of it to accumulate and then send it out in one big response. You need to frame the data as often as possible. So we need to give the runtime a clue as to when to do that. When we used the Spring MVC style REST controller here, the return value of the signature, that gave the framework an idea of when to do that. It knows that this is a publisher of type T, where T in this case is a movie. But when you send back an instance variable, as we did here in the first one, this one here, Java doesn't know of what kind of variable, it doesn't know what kind of variable this get events returns. At runtime, Java doesn't have the ability, using reflection, to answer the question, what is the generic parameter of this instance variable? It can only do it for subtypes, right? Well, Kotlin has a kind of a cute way of getting around that, using something called a macro function. And all you need to know is that it's still inserting that parameter for us, but the compiler is doing some work so that we don't have to worry about that. So behind the scenes, we can say body, and then we're going to say I've got a publisher of strings, and it's going to work. We don't have to say string, class, whatever, right? Class Java. That doesn't need to be done. You could, but you don't need to. So now let's build this endpoint here, this publisher. We're going to say I've got a web client. I need to use that web client that we just created. So we're going to say client, and I'm going to use the functional bean definition here, the functional bean registration DSL. I'm going to say, give me a reference to the web client there, right? This is a typed reference. This is actually if I assign this to web client, it still works, right? The compiler knows that this is a web client. So I can now use that bean definition. I'm injecting that bean definition sort of by saying, give me a reference to that. And I'll say client dot get dot request, retrieve, and I'm going to turn the response that comes back into a type of publisher, right? So what I'm going to do is I'm going to create some client-side representations of the data that we had over there, right? So val ID string question mark equals null, val title string question mark equals null. So that's that one line equals all the stuff that we had to do with Lombok, right? That's saying I need a Java bean with an immutable getter for both title and ID, and the values can be null. Please do that for me. Okay, so now we're going to say, give me a collection of movies, and then I want to map the data that comes back. I want to extract the movie title. I want to say movie.title, right? And that's giving me a publisher of string. Now, of course, this movie bit here is a little extraneous. It's a little superfluous. If I just omit the lambda parameter and just call it, that's the same exact thing. It's equivalent to saying movie arrow movie.title. But now I'm just saying it. That's the implicit name there. All right, so we've got that. That's my edge service. It's an API adapter, right? I'm adapting the, I need to set up a few things here. Server.port equals 8081. And I need to disable the security. Otherwise, it's going to run and fail utterly and catastrophically. So there we go. All right. So it's going to adapt the data for the client. It's going to provide a client-specific view of the data, and that's what we're doing here. That's a very simple example. It demonstrates the client, demonstrates how to talk to a downstream service. Let's see if that works. So we go to...
You want to use generics in the body to flux?
Didn't I? Oh, yeah. Thank you, my friend. Yes, exactly. Look at him. All right.
Like I said, I'm the talkative one, so.
Look at that. He's right. That can get even better. See, the Kotlin DSL has all sorts of macro functions here, so that was even cleaner. Thank you.
It may be syntactic sugar, but it is really
sweet.
Good syntactic sugar.
Oh, yeah. So names, titles, I'm sorry. Thank you, my mob programmers. All right, there we go. So we got the data that gets sent back, right? So that's one example of a very simple edge service. We're just adapting the data from the downstream API. Another thing, a lot of other concerns that you might have here are more generic. Edge services are typically, they're a first port of call for requests coming in from the outside. You adapt them to the downstream service, and these are cross-cutting concerns. Here, I've semantically altered the response. I've actually had to interact with the data and filter out some of the data and respond accordingly. But I can also do a lot of cross-cutting things. I could, for example, interpose authentication, or rate limiting, or filtering, or all sorts of things here. Now, we have a brand new project called Spring Cloud Gateway. Spring Cloud Gateway is a new project that we've just introduced. It'll be in Spring Cloud Finchley. Spring Cloud Finchley is waiting on Spring Boot 2.0. So Spring Boot 2.0, and then in short order, maybe a month later, Spring Cloud Finchley. That's due, I'd say, first quarter next year, right? Mm-hmm. Spring Cloud Finchley has this new project called Spring Cloud Gateway, which is fully reactive from the ground up. Because remember what I talked to you about earlier? We talked about how when you call a downstream service, you need to be able to signal to the downstream service that I can only handle so many records. Please don't overwhelm me. Well, that's exactly what a proxy needs to do. Gateway is an API gateway. Spring Cloud Gateway is an API gateway. It can handle things like proxying data. So let's use that now to interpose, to stand up a couple of endpoints here that use the gateway itself. So we use the val builder equals ref route locator builder, all right? And I'm going to use builder.routes to create some routes. And the routes that I'm going to build, I'm going to create one very simple one. I'll say route and the path that I'm expecting. So I'm saying when somebody goes to my edge service on port 8081 /proxy, that's this path. I could also say and host or whatever. I could actually I could do more abstract things like foo.com. If it's foo, more realistically, it's going to be like this, right? Foo and path. I could say when somebody goes to localhost or asterisk some virtual host foo.com and path proxy, then I want to call this URI, and I could do anything. I could call google.com port 80, right? I could call localhost 8080 /movies. I don't need this host because I don't have any vhost on my local machine, but there's that. And of course, if I'm using Eureka, if I had Eureka, I could use a URL of the form lb : foo-service or movie-service, where service is the name of the movie in the repository, right? So that's the generic form there. Now I'm going to leave it like this just to demonstrate what's happening. Let's give it a simple go here. All this is going to do is it's going to blindly proxy the data to the client. And again, a common example is this, is if you're building an HTML5 application. Your HTML5 application shouldn't be making cross-origin requests to all these downstream services. So you can just point them all to this gateway service, and it'll proxy the data for the client. OK, so here we are. Localhost 808081 proxy. All right, there we are. Not bad. So let's do something a little bit more realistic. We've got, what, 10 minutes?
10 minutes.
10 minutes, yeah. So we're going to do something a little bit more interesting here. We're going to use the gateway to rate limit requests to the downstream service, right? In this case, it's kind of redundant because we already got a reactive thing here, but we may have a downstream service that is fragile, that falls over a lot, right? Imagine your typical PHP on WebSphere kind of thing, you know? Is that a thing? No. But I imagine if it were, it would fall down a lot. So we don't want
PHP or WebSphere. That way you covered it all.
Yeah, there you go.
Sure.
So my point is, I want to have an endpoint that I want to protect. I want to make sure that I can't overwhelm it. So I'm going to use a rate limiter here. And so I'm going to say route, and I'm going to use the RL. I'm going to say ref request rate limiter gateway filter. Is that it? No. Maybe? Rel dot, yeah. There we are. So apply, and I'm going to use the Redis rate limiter here, args, and I'm just going to provide how many allotments, how many requests do I want to allow to go through per second. So right now I'm going to just say something trivially small, like 5, and I'm going to burst, if I need to 10, right? So Redis RL, and whoops.
1.0, yeah.
Thank you, sir. So there's that, and now I'm going to say route. I've already got that. I'm going to say path, and we're just going to call this RL. URI is equal to HTTP localhost 8080/movies, and I'm going to interpose. I'm going to add this filter here. So I'm going to say filter pointing to Redis RL, right? So there's my filter. Now this filter, what this is going to do is it's going to look at the incoming request, and it's going to need some way to measure, to keep state, right? It's keeping track of how many requests have arrived per minute. It has to keep that state somewhere. So we are using Redis. You saw we added Spring Boot, starter data, Redis Reactive. It's on the class path. It's going to use, by default, a key in Redis to figure out how many requests we should allow, how many we should keep going, right? And this is nice because if you have 10 services or 1,000 services, and they're all load balanced, you can still have the sum total of 5 requests to this downstream service. The state is stored in Redis, not in process or in the JVM. That key that it looks up in the Redis data store is configurable, right? You can provide something called a key resolver. By default, it's going to use the authenticated principal making the request. So if Mark makes a request and he's logged in, it'll say Mark can only make 5 requests, or if Josh is making, he can only make 1 because he's a terrible person. So, you can provide dynamic rules there. You can do all sorts of things to say this person or that person should be able to use these many requests, right? So there's that. We need to configure Spring Security, right? And this actually gets us to our last sort of piece here, which is that we have Spring Security, reactive Spring Security here, right? The last thing that we want to do when we move to the reactive world is to bring in classic Spring Security, which by default is going to store things in a thread local. That thread local doesn't make a lot of sense in the world of reactive programming, does it? So in Reactor, you have this idea of a context. A context is like a dictionary. It can store keys and values, and it gets propagated along the pipeline. It gets propagated along the stages in that reactive pipeline that we saw earlier. Spring Security uses that to great effect. We've adapted Spring Security to work just fine in this reactive world. So that's in Spring Security 5, which was just released. So I've got that on the class path as well. So I need to configure that. Now, in order for Spring Security to work, there's 2 concerns that you need to think about when you think about security. The first is authentication. Authentication is the very simple question, who's making the request? And there's a whole number of different ways to do this. You could talk to an identity provider of your specification, OAuth or SAML or Kerberos or LDAP or whatever, or you could just provide a hard-coded list of usernames and passwords, which is what I'll do here. I'll say map, reactive. Oh, I have to go back and bring in Spring Security. Okay. So I'll say map, reactive, map, even, reactive. There we are. So I'm going to create a user details service. This is a reactive version, and I'm just going to create a hard-coded thing here. I'm going to say user.with default password, and then the username will be user because it's user, and the password will be password because it's always password, always.
Super secure.
Right?
Yes.
And then roles will be user, right? There we are. So this is my user detail service. This is going to answer the question, given a request that's an authenticated HTTP basic request or any kind of request that has a username and password in the request, if it matches this user, is it authenticated? Yes, it is in this case. So that's the first question. The second thing we have to answer is authorization. What privileges, what roles, permissions, rights, authorities does the authenticated user have once it's been authenticated? Can it make admin changes to the whole service, or can it just read only? Is it read only, right? You describe that in the authorization section, right? So I'm going to create a bean here to handle authorization. So I'll say HTTP equals ref server HTTP security HTTP, and I'm going to say HTTP dot HTTP basic. I want to use HTTP basic. That's nice. I want to say that I want to also handle some authorization. I want to mask off certain parts of the application. So I'll say any exchange has to be permit all. I'll make everything except for one particular endpoint permit all. And I want to have a particular endpoint called RL that is authenticated, right? And then I'll say that I want to build it and provide it back to as a bean. So I'm using the Spring Security 5 DSL here to build, to describe the authorization. I'm saying use HTTP basic, lock down everything except for the open up everything except for the RL endpoint. And I'm doing that first, of course, because that's more specific. And then otherwise build. So that should work. Let's go ahead and see if that works. Let's go ahead and run it.
If you build it, they will come.
Yeah. That's in a movie somewhere.
It is.
Yes.
Or
it's a good thing we have 10 minutes. 2 hours. Field of flux.
if we keep talking, will they let us?
Yeah. Oh, it's another one. Okay, so let's see. Curl. HTTP. What am I doing? HTTP 8081.
Yes.
RL, right? And what's the username and password thing? Auth. User.
Yes. Yep.
PW, right?
Perfect.
Password.
Oh, password, yes.
What? Did I do
Oh,
that wrong?
-- auth. Sorry, missed that. 2 dashes.
Sad.
Perfect.
Like that. There we go. So that worked. Let's prove it worked by changing it and breaking it. Doesn't work, right? I get authenticate basic realm. So that's working. Obviously I'm making much less than 5 requests a second. So now let's crank it up a little bit. We'll say while true. Well, first we'll say, while true, do done, right? So let's see. 2 requests.
There we go. There we go. Looking for it.
Kill. So angry at me. Close. Let's try this again. Computers. While true, do curl minus
-- auth.
uv curl.
Oh, curl. Never mind. Carry on.
vu user pw password http localhost 8081 rl done. Okay. There you go.
And there we see it. Yep.
So here it says 429, too many requests, right? But clearly some of them are getting through. 429, 429, 429, and there's some data, right? So we're able to implement a very, very simple rate limiter, for example. We could do a number of other things. We could do, like we said, we can do load balancing. You can introduce a circuit breaker. You could actually use the gateway to circuit break requests to the downstream service as well. So you have a lot of options here. All right, my friends, we've ever so briefly looked at just a number of things. We looked at building web apps using Spring Web Flux and the Reactive Web Runtime. We looked at Reactive Spring Data. We looked at security. We looked at the Java DSL and Kotlin DSL. We looked at building regular REST controllers. We looked at Actuator and Observability. We looked at Spring Cloud Gateway. All of this is built on the premise of, or on the fundamentals of Reactive support in Spring Framework 5. This is just the beginning of the journey. I cannot wait to address you all next year. We can't wait to address you all next year, where we can talk about where we've come, or how far we've come since then, or since now. So with that,
I think we're done.
I think we're done, my friend. Thank you so much.